Gang, this is going to be a quick introduction to something called a difference quotient. A difference quotient is basically a function, so we have to remember a little bit about functions. If I give you g of x equals negative x squared plus 4x plus 1, and we want to evaluate that, so for example, letter A says find g of 2. Now you'll remember that that simply means you're going to plug 2 into the function wherever there's an x. So replacing x with 2 gives you, what happened there? Went back. Replacing x with 2, if you replace all the x's with 2, you can evaluate your answer and wind up getting an answer of 5. If you do the same thing with a variable, for example, letter B says plug in t, replace all the t's with an x. So if we do that, then you get this. So replace all the x's with a t, and then if we simplify it, you get your answer. And then the last one, letter C, said replace all the x's with x plus 2 this time. So they're getting increasingly complicated. So every x in the original function gets replaced with an x plus 2, and then you have to use algebra to simplify it. So x plus 2, quantity squared, we're going to need to square that out, FOIL that out, and you get x squared plus 4x plus 4. And then distribute the 4 across, 4x plus 8. Don't forget to distribute the negative across. That's what we did there, distributive property. And then finally go through and combine like terms. Notice the negative 4x and the positive 4x cancel. The negative 4, the 8, and the 1 can get added together, and you get your final answer, which is negative x squared plus 5. So that's just a reintroduction to the idea of plugging things into functions. Now let's move on to difference quotients. This is a difference quotient. You do need to write this down and remember it. It's an important thing we're going to be using throughout the entire year, and I will give you a hint, this is on the final exam, so we are going to be using it the whole year. One of the most basic definitions in calculus employs this ratio. Here's the way we start. We start with some function, f of x. So for example, let's start really simple. F of x equals 3x squared. Step number 1, we're going to replace all the x's with x plus h. So here I do that. And see how I replaced all the x's with x plus h. Then I'm going to simplify it. X plus h, you need to FOIL that out. X plus h times x plus h. FOIL that out, and you get that answer. And then distribute the 3, and we get 3x squared plus 6xh plus 3h squared. We're going to hold on to that because the next step, we're going to subtract the original function from the expression. You're going to want to use parentheses. So here's the expression we just got on the previous slide. And now we're going to subtract the original expression, the negative 3x squared. When we do that, we're going to simplify it. Notice that something interesting happens. All of those things that have x's but no h's, they cancel. The 3x squared and the negative 3x squared cancels each other out, and you're left with 6xh plus 3h squared. In other words, the only things left have h's in them. Next up, we're going to divide the expression by h. So take that expression that you just got, divide everything by h, and if we do that, simplify this expression by factoring an h from the numerator. So the first one, we do 6xh plus 3h squared. We factor that out, and we cancel out the h. And drum roll, please. Your final answer is 6x plus 3h. All right, we do one more example, and then I'm going to turn you guys loose. I'll spin it around just so it gets the idea. All right, here's another one, slightly more complicated. X squared plus 5x. So first step, I'm going to replace all the x's with x plus h. So if I do that and then FOIL that out, x plus h squared, and then distribute the 5 across. Now subtract f of x from the above expression. So I'm going to subtract it. That's my new expression. I'm going to subtract the original. So here's that step. The new expression, subtract the original. When I do that, the x squareds cancel, the 5x's cancel, and you're left with just those h's. Finally, I'm going to divide by h. And if I divide by h and I factor out an h out of the top, and you'll notice that there's your final answer. And that's how you do a difference quotient. I have you try one right now. So try this one just on your desk or on a piece of paper somewhere, and let's see how we do.